Good morning, or whatever time of day. We are going to talk about the period and amplitude of trig graphs. Today we're going to talk specifically about sine, cosine, cosecant, and secant. I'll make another video for tangent because there's a few differences, so I'm going to do that later. But for now, we're going to do period and amplitude of trig graphs. Period is what this B here controls. And what that is, if you remember, is, hold on, let me write the word period. So whatever is multiplying the x is the period. It is the space it takes to complete one complete cycle of that kind of trig graph. So for example, since sine starts like this, well, you can't see it. Sine is normally like this. One complete cycle is this part. So however long it takes to complete that cycle is a period. And obviously sometimes it can be more of them or less of them. That's period. To find the period, you just take 2 pi, so one normal cycle of the sine curve, and you divide it by that number that you have for b. So if there was nothing there, like in the base sine or whatever function, then it takes 2 pi to complete that cycle. But as soon as we divide it by whatever we have here, that's telling us how many cycles will be, or how long it takes. From there, it's good to find the interval. And for these graphs, you're just going to take the period and divide it by 4. And that's going to work for sine, cosine, cosecant, and secant. And I'll show you some examples of how that works in a few minutes. The other thing that we can control, or we're going to learn about today, we're going to do the D and C later, is the A, which is amplitude. Amplitude is the height of it from the midline, just where you could fold it in half. Okay, so again, if we take out this graph, it would be like just going up and down. It's a bigger one, a vertical stretch or compression. Where the period is a horizontal stretch or compression. I should probably have written that. All right, to find or to graph the amplitude, really, you just need to picture where the midline is, and I'll talk about that when we get to the graphs. And the other part that you need to know is if this is negative, it reflects over the x-axis. And again, I will show you some examples of all of those things, but this is the information that you need for right now. Later, we will talk about the C and the D, but for now, let's get used to graphing these suckers with the amplitude and the period only. All right, so if you need a minute to write all of that down, just press pause and write it and come back. All right, welcome back. So we're going to do just a couple examples together, and hopefully this will help you see how all of these things work together. The first thing we're going to do is graph 2 times cosine x. So we're going to draw ourselves a little graph, but we're not going to put any labels on the axes yet. If you think about we'll graph this one first, and then we'll do the normal. The first thing we want to do is figure out the period. Remember that period is 2 pi divided by b. This is where b would go. It would always be right with the x. There might be some parentheses around it or whatever, but that is b. So our period is 2 pi over 1, which is 2 pi, the normal period of a cosine function. It's helpful to find the interval to graph it. So we're going to take our period and divide it by 4, which will give us some key points that we can graph. that equals pi over 2. So we're going to set our 5 key points. Because we don't have any other information yet, as far as the C or the D, we're going to begin in our normal spot of 0. And we're going to repeatedly add pi over 2 until we have our 5 key points. Now, those are not simplified, so I'm going to go ahead and simplify them. Really, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to set that on our x-axis. One cycle, the period, is going to be 2 pi, and then these are going to be our key points, our interval. Obviously, we can go backwards using the same interval and continue. All right, so the period is done, the interval is done. Now we need to look at the amplitude because we got that in this problem. The amplitude is 2. In order to use that to graph, we need to talk about the midline, and the regular midline of cosine is the x-axis, so y equals 0. That's going to change when we add more things to this equation, but for right now, it's going to be 0, which means it's going to go up 2 and down 2. Cosine, I'm going to graph its normal curve on here, normally starts at 1 and looks like this. I'm just going to draw that super lightly so you can see. But with this change in amplitude, it's going to start at 2. That's what amplitude does. It's still going to cross through those key points that we said, but you can see that this graph is different. It is a stretched vertically graph. The period is the same, but the amplitude is different. It's stretched vertically. All right. And just in case you need to kind of write this on here, this is the midline. And you can picture that because if we folded this in half, they would be even on both sides. All right, let's look at one where we can change both the period and the amplitude. All right, and again, if I went on too fast, go back and pause or replay or whatever it is you need to do. All right, so we know we're going to be graphing this, so we're going to draw ourselves a little axis, but we're not going to label it yet. We need to find how to label it by using the parts. First, we're going to find the period. Period is 2 pi divided by b. So in your head, think about which number is b. Hopefully you thought of 2. So the period is pi. The interval is the period divided by 4. It's going to give us the point. So we can't simplify this. This is good. We do not have any other shift as evidenced by the fact that we're only given here period and amplitude. So we're going to start at 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Now I'm just showing it that way. Of course, we would simplify that to 0, pi over 4, pi over 2, 3 pi over 4, yes, and pi. So when we make our graph this time, instead of having the axis go to 2 pi, it's just going to go to pi. And we're going to fill in our other important points. And I'm just filling in a few extras. That would be 6 pi over 4, which would be 2, 3 pi over 2, if we kept going. All right, so period is done. We have our key points on the x-axis. we need our amplitude, or how high, how much we're going to stretch this vertically. The amplitude is 3 from the midline. And again, we have no shift to our midline. We have no horizontal shift and no vertical shift yet. So the midline is still y equals 0, which is the x-axis. All right, so since our amplitude is 3, we need to go up to 3 and down to negative 3. All right. If we were graphing the normal sine function on here, it would start at 0, and then at pi over 2 it would be at 1, and then at pi it would be at 0, and then at 3 pi over 2 it would be here. So really, if we were graphing the normal sine, it would look like this. But we have compressed it horizontally, the period, and we have stretched it vertically. So let's graph it. Still we have 0, 0. Our next point goes all the way up to 3. Back here, down to 3, back to 0. And if we wanted to, we could keep going. 3, 0, like that. So if we pull them together, and obviously my graphs are not drawn perfectly to scale here, but you can see that this is both taller and skinnier than the base function. Parent function, I guess would be better to say. All right, I'm going to do 2 more examples with you, and I hope that you're starting to catch on. All right, so for this one, we're going to actually use the secant function. So make a little note to yourself that instead of graphing that one from your brain, you're going to graph cosine 5, cosine 1/2 x first, lightly. Okay, so we're going to do that part first. We're going to need our graph, but again, not labeled. We have to figure out what our labels are going to be. To figure out our x labels, we do the period, which is 2 pi divided by b. In this case, which number is b? 1/2, which is 2 pi times 2 over 1, if I flip that right, so 4 pi. So think about what that means in your head. Is this going to be compressed skinnier, or is it going to be fatter if the period is 4 pi? And we can see. We're going to use 4 pi to find the interval. So 4 pi divided by 4 is pi. We want to find our key points, and again, no horizontal or vertical shift yet. We haven't even talked about how to do that. So we're just going to repeatedly add the interval to get a set of points to graph. They're all simplified. So now we know how to label the x-axis. X-axis labels are done. We're going to go to the amplitude to label the y-axis. In this case, the amplitude is 5. The midline, because again, we have not even talked about how to shift the midline, is going to be the x-axis, y equals 0. So we need our amplitude 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. We're going to graph lightly the cosine function first. Cosine starts, our parent function starts at 1, so now our parent function will start at 5 because the amplitude is 5. We're going to graph our key points. I'm doing some extras just so you can see. Whoa, what did I just do? Oh, no, that's right. Okay. I was thinking I was doing the parent function for a second. All right, so we're just very lightly graphing cosine on there. And we're going to use that to figure out secant. Now, if this was cosecant, you would use sine. Wherever it crosses the x-axis, that's where we have a vertical asymptote when we're talking about secant and cosecant. That's because if you think about it, on these two axes, if on the unit circle, pi is, we already extended these, but these numbers, pi and 3 pi, are on the x-axis, which makes them undefined. So we have our asymptotes right there. And then to graph these, this secant function, all you're going to do is use these takeoff points to graph. Like that. So you're just going to kind of use those and skim them. They're tangent to each other. They touch at just one point. So the green is the graph of 5 secant 1/2 x. All right, I'm going to do one more with you. If you feel like you get it, go ahead and leave and practice. But the last one I'm going to do with you doesn't have such beautiful intervals. And I know people get confused by that. So I'm going to give one example like that in hopes that that just helps with any confusion about when the numbers have thirds and sixths in the denominator or other numbers. So let's look at one more. Y equals negative sine 3x. So we want to graph this. But again, we do not know how to label the graph. We need to figure that out. First, we're going to start with the period. This will label our x-axis, 2 pi over b, and in this case, b is 3. So our period is 2 pi over 3. That means it's going to take 2 pi over 3 to complete one cycle. Now we need our interval. The interval is the period divided by 4 for sine, cosine, secant, and cosecant. So that's the same as 2 pi over 3 times 1/4. 2 pi over 12 equals pi over 6. So when we find our key points, again, no horizontal shift here. We're going to start at 0, pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. Simplified, 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And I know when I first started doing these, or again started doing them, I was like, where do I put those points? But think about it, these are equally spaced points. So even though the numbers are different, we're still able to just do them in quarters like that. So sometimes it can be hard to really visualize where those go, but that's one way to do it. All right, we have our x-axis labeled. Let's label our y-axis by looking at the amplitude. In this case, it's -4. The negative means it's going to reflect. Over the x-axis. The amplitude is -4, and the midline, again, because we haven't learned how to shift that yet, is y equals 0. So this can be hard to visualize. I'm going to sketch it with a positive amplitude first, and then very lightly, and then I'll show you how it switches. So this is sine, so we start at 0, 0. Oops, I never labeled my y-axis. All right, so if we were doing this with a +4, we would do that 0, then up to 4, back to 0, down to -4, back to 0. Okay, but it's negative. So instead of going from 0 up to 4, we're going to go from 0 then down to 4, back to 0, now up, like that. So you can see it's a reflection over the x-axis. All right, hopefully that was enough to give you a good start and a good strategy. We will work on adding in those shifts horizontally and vertically over the next couple of videos, I guess. But for right now, hopefully you got this. If you have any questions, let me know.